This mark, this is, you sent this in, so you know where this is.
Yeah, I'm told in Western China.
Okay, so they've seen this one.
Yeah, Chengdu.
But, you know, this is quite fast.
Yeah.
Because it's set up well, the board, you know, they've got this weight here, they've got this quite low to the water, it keeps the boat in a good at a good position. You know, so the board the tri-hole started to work really well. This is the high-speed river boat. I'm just going to forward it on a bit. This is fast flowing water.
Have you used this before?
I have used this boat, yeah. The
So,
problem with it is it's really quite big. It's quite long.
quite big.
Yeah, it's probably about this tall.
Do you think this boat can perform?
The data here, it collected data, but it wouldn't be good. If they went to 100 meters upstream, it was a perfect size.
Okay.
You know, so they were more here testing that the boat actually worked. But they did get data, and it was acceptable. I won't say it was good.
Do you have this data?
I'd have to struggle. I'd struggle to find it, but it is available, that data. Do you do any deployments from cableways?
We plan to do it.
Okay. Cableways are a really useful way of doing it. This is the US. This is in Colombia. So this is manned cableways where the people sort of sit in the cable and they wind themselves across as they go. This one here, this is in Austria. And again, sort of using the counterweight here to keep the board in at a good. The whole setup is really important about this. You know, the good ones, you see they put the weight there.
To keep the nose down.
Yeah, but not too down. That's the key. Whereas this one, they haven't put a weight on, and you see the board is lifting up. And once the board is lifting up, the beams are starting to look in the wrong place. They do compensate, they measure the angle, they compensate for depth and everything, but we're now looking at data over there and not where the rest of the channel is. This is a portable cableway that they use up in Greenland within the Arctic Circle. And both of these have a winch at the one side where they sort of wind it across. Other ones have mechanical winches. The problem with a cableway, they're normally quite expensive to install and to maintain. And they have a lot of safety issues about them. Some people put a cable across the river, and to ensure that they get a nice smooth crossing, they put a remote control device onto the cable, and then just as you would with your remote control car, you just sort of transfer it across the channel and bring it back. This one's manufactured by Ocean Science. This one, just the user in France just made his own one. Where's this, Mark?
This is in China. So, yeah, this is a cableway system, sounding weight system where they carved out the center and they put the M9 right in the middle.
So
It's a good-
What's the material of the boat?
Be aluminium, probably.
Oh, okay.
Or lead or stainless.
It was lead.
Was it? Okay. This one in South Africa. They will get a really good measurement here from this, because that instrument is just nice and smoothly going across. It's not jolting.
Very small.
very slow. The canal's moving very slow, so they wanted the boat to go across really slowly. The speed of the canal, I don't know.
Less than 0.5
oh, less than 0.5, less than 0.1.
Less than 0.1.
Yeah. Bridges are people's favourite ways of using them. They're also where we get the biggest number of errors come from. Okay? Typically, because of the eddy that is generated around the bridge pier. Okay? They try to get they're too close in, the boat starts being pulled up towards the bridge, it starts rotating around, get a lot of problem. If you are going to use it from a bridge that has got a bridge pier, make sure you let the boats go out a long way and put a weight on the front. That would have been ideal then. So this bridge here is the same as this one. This water here was going 4.1 metres per second. If it's a single span bridge, that's great. That's ideal.
Yeah.
This unfortunately doesn't show it. This is a really quite ancient bridge. It's probably about 800 years old bridge. Okay, but it's got multiple arches. And it's really not a good site for using the instrument at. Kayaks. Kayaks are really good actually. Really good. Kayaks are designed to move very easily through water. Okay. In this one, they've attached it to the front. This one's really nice. They've made a hole in there. They made a little well go through. They put the instrument through there, and then he literally kayaks across the river while collecting the data. This one is an inflatable kayak. It has a hole in the centre. Okay, put the instrument in, inflate the kayak around the instrument, and again that works really, really well. Towing an instrument is never good. Never, never good. You get the interference from the engine, maybe magnetic interference, definitely turbulence interference in that. Here, he sort of took the opinion that he's very gently going, but with every paddle stroke he was doing, you get the vortex sort of trailing behind. They would have been measuring that. So I would definitely say never tow one. If you've got to use a boat or anything like that, put it over the side or put it over at the front. Okay. Ideally, well away from the boat. So have a rod going out the side and attach the instrument onto that. This is actually on the Danube River in Romania. All they use is a ladder. Think about the height of your, if you've got GPS, about are you going to be interfering with your GPS? If you're too close to that, or if maybe the extension's not that high, you're going to be you're blocking a lot of your satellites because you're too close to the boat. These are some fixed mounts for them. Here, they've definitely got the GPS down too low. I would have had an extension cable on the GPS and put it on the top of this pole, up here.
So how you should prevent for the mechanical effect by metal ball or motors?
Yep.
We have a gun, maybe the calibration compass or 1 millimeter or 5 millimeter or 10 millimeter.
With the compass calibration, okay, so on, let's say on this one, let's say this is a magnet, a ferrous hull. Okay. Put it in a situation like this, okay, and then calibrate the compass. And it will it will work out what the magnetic interference is from the boat, but it becomes important, it really is important that we do 2 complete revolutions, okay, so it can see it through all planes, and it takes that magnetic interference out.
So more wire, more wheels.
Yep.
Yeah, actually I have took about 5 minutes to convert it and didn't. It's already acceptable. If in this situation, can I just pause that and use maybe the GPS compass for my
Yep, for sure.
Yeah, right.
Yeah,
So
most definitely.
But how about gyros? Gyro, there should be problems.
Sorry, say again.
I mean, gyro to the pitch rolls.
Oh, the gyro compass
Yeah.
and all that.
Yeah.
Yeah, well, you could feed that into the data. The only problem is you only have we have only one port that we can feed that data in.
Yeah.
Okay, so you can have a GPS compass that comes in, we can have a gyro compass that comes in. There's a number of different ways. You can take it from an external compass somewhere else.
So I can use another third party or external sensor.
You could, and you could bring that in
Yeah.
using the cable. And this one here.
Yep.
Okay, so that can be brought in. The problem with that is that if we're using that on a remote boat, you cannot use the long cable. SonTek don't like it, but the UK office for SonTek have actually made a cable with a T off, so you can actually have that on the remote boat as well. Okay, so you can bring in external devices as well as the SonTek device.
So they can convert the data each sample or have a time?
No. As long as it's coming in, okay, it's the M9 put it all together each time. Everything is.
Oh.
That's why we save the GPS data. Any GPS, whether it's GPS compass or GPS, that's why we say 10 hertz is what we require. Okay.
So I always require as a customer to be buy the hemisphere.
Yep. You can buy the V102.
Conversions.
I noticed that this one has got GPS compass on it as a heading. The Hemisphere V102, okay, is only differential. Okay. The later Hemisphere GPS compass.
103 is more.
No, but it is, but it's big as well. Okay, it makes it difficult on this boat. I think there's a 105 now, which is back smaller and has RTK capability.
Okay.
This is, if you're going to really install it on the boat, it's much better to put it off the bow of the boat. Mark, you said you ran through the video of the...
video. I think it's the top right.
Yeah, it's not a video, that one. That's
There's a footer, but that's the same from South Africa.
This here, this is the really old river pad. But the important thing about this is the way they've just got the rope going out. This is a flexible pole, and so as this boat is pitching and rolling, the pole flexes and the instrument stays flat on the water. It's the same as having the pivot point on the front of here. In the next slide, it's not the greatest video, but here you see they have it with that same mount with the pivot point, so that the instrument stays flat. Here on the other boat, they've got it directly mounted onto the bow of the boat. The problem with that is, as their boat pitches and rolls, the depth of the instrument changes, and that's definitely not good.
We have people there for the whole.
The most common way is the manual use of one person on one bank, another person on the other, and one person pulls it across to one side and then the other person pulls it back and does the mission. It works really well. All I would say is I would not connect it to either side of the board, because when you connect it either side of the board, as they're pulling, you get this sort of movement going across. It would be better to have it at a central pivot point. Okay, and then the boat just sort of does this at worst. Okay, rather than that. So here, this is in Sweden, and they put a 4-point pulley system in there to help them get a nice smooth crossing of the channel. How do you get the rope across the river? These are all real photographs that I've seen of how they get the rope across the river. Golf ball with a bit of fishing wire on it. Fishing line, get it across. This one is a gun, a crossbow this was, with again the fishing line. This is a dog trainer. It's got a little gun cartridge in there and it fires it across. You put a different size cartridge in for however far you want it to fire. This one was in Austria.
You provide this.
Yeah.
That's why his bag is stuffed.
Yeah, I brought this one in. I thought they'd be all right with that. And this is the cheapest one. A little ball for your dog to chase. Okay, and attach a fishing line to that and throw it across the river. You can get 30 metres quite easily with that. Which is something that you probably couldn't do with a throw line. You could probably only decently get about 15 to 20 metres with a throw line. Remote control boats are becoming hugely popular. Okay. There's a number of different ones. This one is useless. It does about water speed of 50 centimetres per second maximum. No good. This one is from Finland, about 4 metres per second. This one from Korea, 2 metres per second maximum. This one, 4 metres per second. This one, 5 metres per second. I don't know what speed, this is a hollow craft.
5 meters per second. This one.
That's 5 metres per second.
Wow.
Okay.
It's a new one.
That's
It's
UK.
about 3 years old now. Yeah,
From the UK.
from the UK.
Oh.
The UK government were looking at trying to stop people getting in the water and keeping them safe.
Okay.
And they actually had this one built for them. They they went to a local boat manufacturer and a hydraulics research base.
So
they
nowadays SonTek also.
You can do. Well, actually, it's best for you just to buy it direct from them.
So who sells it?
HR Wallingford. HR. I can give you the details.
5 meters per second.
5 metres per second.
Okay, I think it's time for.
Yep.
Have you almost
For a
done?
break.
Yeah.
I've just a couple more slides.
More slides.
This one is this Chinese one.
Yeah, this is from Guangzhou. Yeah.
This is the ball you showed it.
I've only ever seen this on a video. But this one they say 5 metres per second.
So Chinese people.
This is from Guangzhou.
This is designed for an M9. It's not just a remote control boat. It's designed for the M9.
Design for Vietnam. So where is Vietnam? Beneath the ball.
Beneath the boat. The problem with speed, and we'll look at this in some data afterwards, is aeration. And what that causes around the instrument. Helicopters, they get used. Okay. In New Zealand, so they put an M9 in the bottom of the kayak. I'll speed it up because there's a bit.
So they can do many sites very quickly and
I think this was flood conditions in New Zealand about 2 years ago. And I think they were able to do 11 sites in 2 days.
11 sites.
In 2 days. And previously they'd have been able to do 1 or 2.
So they hired a helicopter to
Yeah, in New Zealand, helicopters they use them like taxis.
huh?
It's
it's very remote. Not many people, mountains.
I do a lot of kayaking. I used to do a lot of kayaking. And I went to New Zealand to do some kayaking, and I was saying, how do I get to the top of the river? And the guy just said, oh, hire a helicopter. And I said, I can't afford that. He said, no, it cost me to go for them to take me up the mountain with a kayak, 2 of us with the kayaks, 30 pounds.
30 tons.
Apparently this cost them, what's the equivalent? £200 for 2 days with that helicopter. It's nothing. Not when you think how much it costs you to collect data. I think that's we'll stop for now. Yeah, take a break.
好，我们休息一下，大概因为他讲比较久，让他休息久一点。我们休息20分钟好了，45分。OK， 45分请主持进来那个下一个 section。So right now you just more detail about the